Okay, so we're going to look at graphing quadratic functions or graphs. So it's asked us to graph the following equation. F of x is equal to 3 plus 2x minus x squared. For minus 2 is less than or equal to x is less than or equal to 4, where x is an element of the real numbers. So the first thing that we notice from this graph that it is quadratic because we have an x squared in it. So our highest power of x is x squared, therefore it's quadratic. We know that it's going to be an n-shaped graph. And the reason being is because the x squared is minus. So when we graph it, it should be n-shaped. Unlike in linear graphs, when we graph quadratic graphs, we must graph every number for our x value. So if we look at the domain here, so the domain is really important. So minus 2 is less than or equal to x is less than or equal to 4. So the numbers that we have within that value are, we're going to let x equal to, so minus 2, minus 1, 0, 1, 2, 3, 4. So like I said, when we did linear graphs, we would have just picked the first and the last. So we would have picked that one and that one for linear. But because it's a quadratic graph, we must graph each one of them. Just if you look up here, I'll just show you. If you only graph two of them, and we'd end up with this point here and the last point, that would end up in a straight line, therefore it wouldn't be a quadratic graph. We need every single point in it in order to show the curve that we've created. Okay, so the quickest and easiest way for us to do this is actually use our calculator over here. So this is really important. So we would use this in statistics, so I think everyone has a fair idea how to do it. So on our calculator we would go mode 3 and then insert the equation. Remember when you're inserting the equation that alpha, the red alpha, and then the closed bracket gives you x. So just remember that. So if we were to input this into our calculator, so we go follow our instructions, insert your equation, so you have insert 3 plus 2x, so 3 plus 2 alpha close bracket minus alpha close bracket squared equals your domain, so your start point in this case, so start would be your first number, which is minus 2, your end, so minus 2 and then press equals to input it. Your end in this case would be 4, as you can see there. So 4, and your step would be 1, because all of these numbers here are just going up in whole numbers, so that's why it's 1. So we'll do that much, 4 equals, good. Right, and then you'll be given your graph. So your graph, or your table, should look something like you'll have your x values, and then your f of x values, and we all know at this stage f of x actually means y. Let me just move up a bit. So we'll have your minus 2, and then you would have got minus 5. And just do this in your calculator at the same time so you know where I'm getting all these values. 0, 3, you have to press down to get the rest of them. 1, 4, 2, 3, 3, 0, and 4, minus 5. So there we have our x and our y values, so we can just plot them out like minus 2, minus 5, minus 1, 0, 0, 3, 1, 4, 2, 3, 3, 0, and finally 4, minus 5. So now we're ready. These are x and our y values. Now we're ready to draw our graph. So in order to do so, we must plot every one of these points. We know that the quadratic graph is going to be n-shaped because the x squared was a negative. Just pause it there. Okay, so instead of drawing the graph, I'm just after copying in an image of it, okay? So like our first point is minus 2, 5, so we can see from the drawing here, I'll just highlight the points. So there's minus 2, 5, minus 1, 0, so there, it's there as well. 0, 3, perfect. 1, 4, 2, 3, oops, 3, 0. No, I'll just move back over it. And finally 4 minus 5. And they're the 1, 2, 3, 4, 5, 6, the 7 points that we got from our calculator. So these would have been pretty easy just to graph ourselves. Okay, so if you're asked a question on functions, you're generally going to be asked to like interpret your graph. So answer questions on your graph. Okay, so using your graph, find the values of. So these are the questions we're going to do today. Okay, so find the values of the roots of the equation f of x equals 0. So that first one, so f of x equals 0. So we know straight away that when f of x equals to 0, that actually means when y is equal to 0. So beside that, I'd write when y is equal to 0, because that will help us when we're doing that. Okay, so when y is equal to 0, so we'll just get a different colour pen, and we'll go across from when y is equal to 0. So we know that y is equal to 0 right here, as is x. We want to find when y is equal to 0. So what we'll do is we go across to where it meets the graph, okay? And the reason we know we do that, because if they said f of x was equal to 1, so where y is equal to 1, you go to where y is equal to 1 and you go across and then read down. So this is the exact same thing. So this time you're going to where y is equal to 0, going across and reading your graph. And these are the roots of the equation, which we already know as well. So we know that the roots of the equation when y is equal to 0 is x is equal to 3 and x is equal to minus 1. So they're the roots of that equation, which is when y equals 0. Find the values for x for which f of x equals 3. So when y equals 3, so we'll just get a different colour pen again, so we'll get maybe green this time. So when y is equal to 3, so we go where y is equal to 3, so it's here, and we read across the graph. And when y is equal to 3 on this part, you can actually see that's already hitting the graph. So when y is equal to 3, we know x is going to be equal to 0. You can read from your graph. And x is also equal to 2. So that's not so bad. So the next question, part 3. So find the value of f of 2.5. So we know that in place of the x is actually 2.5. So therefore, it's when x is equal to 2.5. So we have to go and look on the x-axis and see, okay, where does x equals 2.5? So let's go to our graph. So about there is where x equals 2.5. So if we go down, we're never going to meet the equation in this case. But we could go up and see if we meet the equation. So use your ruler, go up to where it cuts, so just about there, and then we'll go across from there. So up to where it meets the function or the equation, so the graph, and across. So when x is equal to 2.5, so when x is equal to 2.5, y is equal to, what will we say, about 1.4 maybe, approximately. No. About that, okay? So your graph will probably be a bit clearer than mine, okay? Part 4, so the maximum value for f of x. So the maximum means the biggest value of y. So the biggest or the highest value of y, doesn't it? So like the highest value, so like where is it at its highest point? So where is it at its highest point? Where is it at its lowest point would be the minimum value. So at its highest point, so if we look at that graph, you can see its highest point is just up here, isn't it? So it's just at that tip. So find the maximum value for f of x. So the maximum value for f of x is that point there. So what we call that point? That point is 1 on the x-axis.